Assalamualaikum. My name is Khairun Nisabinti Khairul Anwar. I would like to present about introduction of application Gauss-Seidel method in linear equation. Gauss-Seidel method is developed by Carl Friedrich Gauss and Philipp Ludwig Seidel. This method is developed from the Jacobi iterative method. The Gauss-Seidel method differs from the Jacobi, which is approach in that each component of x is employed in the iteration as soon as it is computed in the Gauss-Seidel method. So the objective of this study is to concentrate on using the Gauss-Seidel iteration method to solve systems of linear equations. Next is problem statement. Problem statement based on this project is to solve the systems of linear equation with the application of Gauss-Seidel iteration method. In civil engineering, all of the critical variables must be considered to ensure it is well functioned. This can also prevent any unwanted incidents like leaking pipes from happening. Hence, determining the maximum stress in a compound is essential in order to understand stress level and its failure behavior. So, we are using the application of Gauss-Seidel iteration method to determine the maximum stress in a pipe.
The Gauss-Seidel technique, commonly known as the Lippmann method or the method of successive displacement in numerical linear algebra, is an iterative method for solving a system of linear equations. It is comparable to the Jacobi technique and is named for the German mathematicians Carl Friedrich Gauss and Philipp Ludwig von Seidel. Despite the fact that it can be applied to any matrix with non-zero diagonal components, convergence is only guaranteed if the matrix is either strictly diagonally domination or systematic and positive defined. In 1823, Gauss only discussed it in a private letter to his student Gerlin. Seidel did not provide a publication until 1874. However, the Gauss-Seidel iteration will not be very useful on a parallel computer since all computation of a Jacobi iteration may be done at the same time. Whereas in Gauss-Seidel, any unknown cannot be computed until the previous unknown is computed. It is a sequential operation. The Gauss-Seidel procedure's iteration formula is follows at the pictures. This section outlines some of the popular techniques to solve large-scale linear equation. The general form of a system linear equation is as follows the picture. The system of linear equation can be written as metric form. For example, A times X equal to B. The Gauss-Seidel method is one of numerous techniques to solve equations, especially for linear equations.
Assalamualaikum, my name is Nurizayan binti Zulkifli. My matrix number is AF200068. So I want to present about the methodology. First of all, the lecturer gave instruction for the project in the class. After that, we start a group discussion and choose the topic of the project, and we choose to solve linear equation using Gauss-Seidel iteration method as the project title. After that, we state the problem statement from the selected topic and state the objective of the project. Next, we write the literature review and create the equation using the selected method related to civil engineering field. Then, we solve the problems using Gauss-Seidel iteration method and specify the discussion from the solution. After that, we write the conclusion of the project and make a video presentation. Last but not least, we complete the report. That's all.
The problem. In a compound pipe, the inner pipe has an internal radius of A equal to 5 inch and an outer radius C equal to 6.5 inch, while the outer pipe has an internal radius of C equal to 6.5 inch and an outer radius of B equal to 8 inch. Given E equal to 30 multiplied by 10 psi, V equal to 0.3, the engineer needs to find the maximum stress in a compound pipe in order to determine how a piping system behaves. We need to find the value of x1, x2, and x3. We will solve the problem by using Gauss-Seidel iteration method. First, we need to rearrange so that matrix A is diagonally dominant. The matrix will be changed into this position. We will get this matrix. Next, we will write down Gauss-Seidel iteration formula. x1 will represent as A, x2 will represent as B, x3 will represent as C. By using the Seidel iteration formula, the value that we got from the formula A, B, and C will be inserted in the table. Since maximum equal to 0.003, that's below 0.005, so the solution is x1 equal to negative 1.4453, x2 2.2024, x3 1.3169.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present to you about my discussion. In this research, we get three linear equations from the problem statement, and each of the three linear equations has three unknowns. The values that we can use to solve a system of linear equations are x, y, and z, or unknowns that fulfill all three equations at the same time. The three linear equations are as follows, arranged in the form of an enhanced matrix that we studied a few techniques in this chapter 3, which can be utilized to solve linear equations problems. After determining the state of affairs, only Gauss elimination and Gauss-Seidel iteration meet the requirements for each approach. It can be utilized to remedy this issue. Gauss elimination is a technique for determining all of the variables as one in equation 1, then remove all x2 variables from equation 2 and x and 1 variables from equation 1. We can acquire an upper triangular system after the elimination process. We utilize backward substitution to find the unknown x, y, and z after obtaining the system. The convergence criterion for the Gauss-Seidel iteration method are that the system must be diagonally dominant. We write down the iteration formula and insert the data after checking the system is diagonally dominating. The approach is used in conjunction with the calculator. We use the calculator to solve the equation and determine x, y, and z till the error is less than 0.005 and the solution to the unknown x, y, and z is found. The Gauss-Seidel iteration approach yielded k equal to negative 1.4453, y equal to 2.2024, and z equal to 1.3169, but the Gauss elimination method yielded x equal to minus 1.4453, y equal to 2.2024, and z equal to 1.3169. Both approaches have slightly different x numbers, but the y and z answers are the same. We use backward substitution to validate the exact answer. First, get the x value by substituting x and y and z into the equation. 4,500x minus 9,231y plus 4,500z equal to negative 7,900. The result of the calculation is a value of negative 1.4453. As a result, we can deduce that Gauss elimination can provide a more accurate response with fewer mistakes.
In conclusion, we choose the Gauss-Seidel iteration method to solve the linear equations to find the stresses in the compound pipe using variable radius of the outer and inner pipe. This is because we need to find more than one stress using various radius in one pipe. Hence, the Gauss-Seidel iteration method is the best method in numerical methods to solve the linear equation in this problem. This is proof that the numerical method subject is really important in the civil engineering field because it has many relatable things to solve the problem in engineering. In addition, we also as engineering students should use what we have learned and apply it to the knowledge that we have to solve all the problems because everything is related to application of mathematics in real life. That's all.